Okay, so today we're going to be working on 12.3, okay? Just like yesterday, we did arithmetic, sequences, and then series. Today we're going to do something very similar, okay? Today we're going to work on something called geometric, sequences, and series. Okay, so the first one is a geometric sequence. Okay, a geometric sequence is a list in which there is something called a common ratio. Okay, so basically in an arithmetic sequence, you consistently add or subtract to get to the next term. In a geometric sequence, you consistently multiply to get to the next number, okay? It could be multiplied by a whole number or it could be multiplied by a fraction, okay? But in either case, it's called a common ratio, and we just denote that by an R, okay? It's usually just the R. So, first thing I want to know is the following a geometric sequence? Okay, is the following a geometric sequence? And I'm going to ask you to explain. So the explanation part is literally just going to be there is a common ratio or there is not a common ratio. That's the only explanation that I really need from you. Okay, so for example, number 1, if I give you the sequence, and remember the sequence is just a list of 5, 10, 20, 40, and ... It could keep going on. Is this a geometric sequence? So before you do that, first thing we want to do is label these, okay? Just like we did with arithmetic yesterday, you're going to start by labeling these. So this is your term 1 or your A1, A2, A3, A4, and you could keep going if you needed to, okay? And to figure out if there's a common ratio, you always take a term and divide by. Yesterday it was subtract, but today we're going to divide by the one in front of it. So we could take A4 divided by A3. Okay, if we did A4 divided by A3, that would be 40 divided by 20. What is 40 divided by 20? 2. Okay, now you can't just check one of them. Okay, you have to check multiple ones. You could also check A3 divided by A2 or A2 divided by A1. So basically you take one term and divide by the one in front of it. Okay, so 20 divided by 10. 20 divided by 10 would give you 2. So does it appear that this sequence has a common ratio? Yes. Okay, so you're trying to figure out, can I consistently multiply by the same thing and get my next term? Okay, but here, what is the common ratio? What do you multiply by to get to the next term? 2. Okay, so is this a geometric ratio? Yes, it's going to ask you to explain why. Common ratio. And you could even write the common ratio is equal to 2. Okay, that's your answer. So is this a geometric sequence? Yes, because the common ratio is equal to 2. Okay, let's try another one for number 2. Same thing, I want to know, is this a geometric sequence? 1, 3, 6, 12, and so on. Does this have a common ratio? Please stop texting. Does this have a common ratio? Now, do you actually have to show all of this work? Not really. Okay, I just want you to think the best way to do this is to figure out how would you get from 1 to 3? What would you multiply by? 3, and I would write it in between there. What would you multiply by to get from 3 to 6? 2. What would you multiply by to get from 6 to 12? 2. Is this the same ratio? No, therefore, is it a geometric sequence? No, not a common ratio. Okay, so literally it's just, is there a common ratio, yes or no, and that's going to give you your answer. Questions so far? And you don't have to be super formal about it. I would just write in between each term. Okay, figure out what is the common ratio. This is work right there. That is work. right there. That's enough work. They're not quite going to be that easy though. Okay? Most of the time it's going to be ones like this. Is the following a geometric sequence? 7 over 2, 7 over 6, 7 over 18, 7 over 54. Is the following a common, or is this, excuse me, a geometric sequence? So is there a common ratio? Now, you could do this kind of the long way, I would say, and actually do the division like this. I would write these, and I wrote these intentionally with a little bit of space in between them, to figure out the common ratio. If I'm just looking at these first two, okay, remember this is your A1, A2, A3, and A4. If I'm just looking between 1 and 2, how do I get from 7 to 7? What would you multiply by? 1 over, how do you get from 2 to 6? 3. So I would literally write what you multiply by in between the two terms. Then look at the next two. How would you get from 7 to 7 when you multiply by? 1. How do you get from 6 to 18? 3. Does this appear to have a common ratio? Yes. I would check, you can't just check 2, I would check 3 at least, just to make sure. Like on this one, if you only checked 2, it may appear that it does have a common ratio. You have to check, not all of them, but I would check at least 3. Here, to get from 7 to 7, you'd multiply by 1. To get from 18 to 54, what do you multiply by? 3. So, is this a geometric sequence? Yes. Has common ratio. Okay, so the first part of your homework is just going to ask you, is it a geometric sequence? Yes or no, and to explain, the explanation can simply be has common ratio or no common ratio. Very simple, okay? That is the appropriate amount of work that at least needs to be shown. Questions so far? Okay, next thing you're gonna do is writing the rule. Okay, so rule for a geometric sequence. Okay, the general rule for a geometric sequence is a sub n. Notice that whenever we're writing a sequence, it's always going to start with a sub n. Same thing happened for for arithmetic. A sub n equals a1. In this case, we're going to do r in parentheses, so multiplied by r, to the n minus 1 power. Make sure that your handwriting is very clear on this. This is a power, not next to the r. Then here, an stands for to find term number. To find term number n, and you could plug in any number there. You take a1 stands for what? First term. And you are going to multiply it by, what is the r? R stands for the ratio to the n minus 1. That's term number minus 1. So a sub n equals a1 multiplied by r to the n minus 1 power. Okay. Now, dependent upon how you guys behave the next couple of days, you may have a formula sheet that has them on, has these on there, or you may not. Okay, so it just kind of depends. If you're turning in homework and being responsible and doing what you're supposed to do, I will probably let you have a formula sheet on your test. If you're not, you have to memorize these all by yourself. And there will end up being 5 formulas. Okay, this is the third one that you're learning, but there will end up being 5. For example, number 4. My bad. I would like you to write a rule for the following. Write a rule for the geometric sequence 2, 6, 18, ... Now, if you're writing a rule, I'm basically telling you this is a geometric sequence. You don't have to tell me if it is or not. I'm telling you it is, so you don't have to check the ratio. And then I want you to write the rule. So in order to write the rule, an, you're basically going to cross out. Okay, so I'm just going to write an, I'm going to write the whole rule again. An equals a1 times r to the n minus 1. An, we're not going to worry about just yet. That's going to stay an, so I'm not going to plug that in right now. what is your A1?
2.
A1 is 2. Multiplied by, what's the ratio here? What do you multiply to get to? Each term is a 3 to the n minus 1 power. Now, can I multiply those together? Absolutely not. Okay? They do not have a common exponent, so you leave them alone. Your actual answer is this. That's your whole answer. 2 times 3 to the n minus 1 power. Now, theoretically, I could ask you to find the 10th term, find the 20th term, okay? Then you would just plug in. You can obviously use calculators on these because it is going to have a significant exponents in there, okay? So you can use calculators. Away, Nikki.
Me.
Put it away. Okay, so you can use calculators on these. Okay, next one, for number 5, same thing. I'd like you to write a rule for the following. Write a rule for 3 over 20, 9 over 80, 27 over 320. I'm not interested in it right now. Write these down. Write it down. Write a rule for this geometric sequence. And I'm basically telling you this is a geometric sequence. Sure. Do it by yourself. So, general rule is going to be AN equals A1 multiplied by R to the n minus 1 power. The AN you get to ignore for a minute. What is your A1 in this sequence? 3 over 20. Multiplied by the ratio. How do I get from 3 to 9? What would I multiply by? 3. How do I get from 4 to 80? 4. Now, if for some reason you could reduce that, you should. Okay? It almost never happens that it should be reduced, but if for some reason you should, or it could be reduced, you should reduce it. Okay? You can check this again just to make sure that you have the ratio correct, but you don't have to. I'm already telling you that this is a geometric sequence. So here, the ratio is going to be 3/4 to the n minus 1. Can I combine any part of that? No. Okay, you cannot multiply any of these things together because they do not have a common exponent. Okay, and they're not the same thing. So you cannot multiply these together. Rewrite your AN, that is your answer. So these are kind of a little bit easier to write than arithmetic sequence formulas because there's basically no combining. You don't have to clean anything up. It stays just like this. Okay, try another one, number 6. Here, I would like you to write a rule and write a rule, and for this one, I'd like you to give the first 3 terms. Okay, if you are given that A1 is equal to 4 and your ratio is equal to -5. If your A1, so your first term is 4, the ratio, what you're going to multiply by, is -5. So we're going to plug into AN equals A1 times R to the n minus 1. I would always write out the formula just so the more you write it, the more it's going to cement it in your head. If you don't, that's fine, but if you make mistakes and don't show much work, there's not much I can do about it. So AN equals your A1 is what? 4 times -5 to the n minus 1. So this is your rule. That's the first part of the question. Then, to substitute, to find the first 3 terms, you're going to substitute. So A1 is equal to what?
4.
You already know that one. It's 4. Do you really need to plug into this to get 4? No, you could. Okay, I'll show you that if you did this, you'd get to the 1 minus 1, which gives you 4 times -5 to the 0 power is what?
4 minus 5.
Hold on. No, you cannot do 4 minus 5. Multiply 4 times -5? That would give you -20. That's not right.
No, by the ratio.
You can, but I'm saying I'm just showing you, well, that's what this whole formula does, is multiply it. So this one would give you 4 times 1, which is 4. To get to the next one, absolutely. You could just multiply by -5 to get to the next one. But a lot of times it's not going to ask you just for the first 3 terms. It would ask you for like, what's the 12th term? So I'm just showing you that this formula does work. Then you could plug in to find A2, or you could just multiply, because this is relatively easy. 4 times -5 gives you what? -20, and A3 would be what? -20 times -5 gives you 100. Is it okay that your sequence goes positive, negative, positive?
Yeah.
Is that okay? Yes, because you are consistently multiplying by a negative number, so that is perfectly fine that it switches between positive and negative numbers.
But always have to start positive.
No, not necessarily. It does not always have to start at positive or always start at negative. Right? It could stay positive the whole time, could stay negative the whole time, but that is okay that it switches between. I'm sorry? As many as I'd like to do. Next thing we're going to do is geometric series. Okay, a geometric series. So this is kind of like the start of new notes. Okay, geometric series. A geometric series is adding up all terms of a geometric sequence. So a geometric sequence is just a list of numbers that you get by multiplying to get to each next term. A geometric sequence is when we add up all the terms in that list. So a series is when we're adding things together. A sequence is just the list. So the formula for a geometric series is S sub n is equal to, and whenever you see S, you should think in your head that that means sum. Sum of all the numbers is equal to A1 multiplied, you're going to do a big parentheses, times 1 minus r to the n power divided by 1 minus r. 1 minus r to the n power divided by 1 minus r. So, for the first one, for number 1, because I kind of restarted notes here. If I would like you to find the sum of the sequence 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256, and we'll stop there. Find the sum of that entire sequence. Now, could you do this on a calculator? Absolutely. You could just add them all together. But the odds of you making a mistake when you're punching in the numbers are pretty high. It's pretty easy because calculator buttons are really little. So here, let's use the formula. So sum of all the numbers is equal to, what's the A1? 2 times 1 minus, what's the ratio here? How do you get from any one term to the next one? 2. You could check this. Okay, you could check it anywhere. How do I get from 32 to 64? Multiply by 2. Okay, you could check anywhere in there. Remember, there is no such thing as having a divide ratio. We are always multiplying. So divide by 3, that ratio actually means multiply by 1/3. Okay, so there is no such thing as having a divide ratio. You're always thinking, what are you multiplying by? So if it's going down, it could be that you're multiplying by a fraction. Okay, if it's decreasing in number, so like 2, 1, 1/2, that kind of thing, you're actually multiplying by a fraction, by a ratio. Okay, so here, 1 minus, we decided my ratio was 2 to the n power. What does n stand for here? N is the total number of terms. How do I know how many terms there are? Count them. Count. A 1, 2, 3, 4, 5, 6, 7, 8. Label it if you need to. That's A sub 8. Sorry, I shouldn't use a highlighter. A little fat. A sub 8. So 2 to the 8th power over 1 minus your ratio is 2. Yes, you actually have to work this out, which is yes, why you get to use a calculator. So 2 times 1 minus 2 to the 8th power, if you do this on your calculator, is 256. Over 1 minus 2 is just negative 1. It is important that you keep the negative there. If we work this out a little bit more, that's going to give you 2 times 1 minus 256 is negative 255 over negative 1. What happens when you have two negatives together? Turns positive. So really, this is 2 times 255. If you multiply it together, 510 is the answer that we're looking for. Now, like I said, you could totally add them all up in your calculator, and that's fine, but you don't need to. Okay, and quite frankly, they're not always going to be quite this easy.
Are there homework if we did add them up?
If you did just add them up, that's fine. But odds are most of your homework is not going to look like that. It's going to look a little more like this. For number 2, I would like you to find the sum of the first 10 terms of the geometric sequence 2 plus 6 plus 18 and so on. So here, I'm not telling you all the terms. So if you wanted to punch them in a calculator, you would have to actually find out what are the first 10 terms. Do I really need all the terms? No. If I'm going to use this formula, what do I really need? Sum of all those numbers is equal to A1. Do I know A1? So I'm going to write this in here. 1 minus r to the n over 1 minus r. So I'm just going to write my formula and then plug things in. Do I know A1? A1 is what? 2. 1 minus, do I know my ratio? How do I get from 2 to 6 to 18? Multiply by what?
3.
By 3. Also, when you're finding your ratios, I would discourage you from using an x. Okay, use a little multiply dot. Do not put x3. Okay, it tends to get people confused. Just put a little multiply dot. We really don't use those x's for multiply anymore.
I think we stopped
You should have stopped it a long time ago, but some people still use them, and it can tend to get confusing when you're adding in, when you have letters in here, so just try not to do that. So ratio is 3 to the n power. How many terms are there going to be? 10. Over 1 minus 3. Do I really even need to know what that last term is? No. So in arithmetic yesterday, you actually had to use the other formula, okay, use the sequence formula to figure out what the actual term was. Here, you really don't. Okay, so here we're going to have 2 times 1 minus 3 to the 10th power is 59049. If you would like to, feel free to use your calculator, verify that. You can do 3 times 3 10 times if you really feel like it. Over 1 minus 3 is negative 2. Here, when we subtract this and simplify, we're going to get 2 times 1 minus 59049 is negative 59048 over negative 2. Do I really need to multiply by 2 and then divide by 2? No, let's be a little smarter here. The negatives will cancel out. What can happen with the 2's? They cross-reduce. So what's your answer? 59048. That's your answer. Don't do more work than you need to. Unless you'd like to, if you'd like to use your calculator, feel free. Multiply, then divide by the exact same number. You will get this answer. Questions on how I did that? Okay, last one. Number 3. Last one, I promise. I would like you to find the sum of, so whenever you see that symbol, this is called the sigma symbol. It means find the sum of between I equals 1 and 7. Sometimes they have i's in the formula, sometimes they have n's. Any variable is fine. It does not matter. If it's an I or an N, you're still going to do the same process. I haven't given you the formula yet. Hold on. 6 times 2 to the I minus 1 power. 6 times 2 to the I minus 1 power. So I'd like you to find the sum of if I plug in 1 through 7 into this formula. To use that sum formula, what do I really need? I need S sub n equals A1 times 1 minus r to the n over 1 minus r. So I need to know what. A1 stands for the what? First term. Can I just look at this formula and can you tell me what is the first term? Some of you said 6. How can you tell that? What does this look exactly like? The other formula, the sequence formula. The sequence formula was AN equals what? A1 times R to the n minus 1 power. Does this not look very similar? It does look very similar, and it's on purpose. The first number is the A1. Do I need to plug in 1 to figure out that your first term is 6? Nope. So let's plug things in here. Your A1 is going to be 6 times 1 minus, can I just look at this formula and tell what the ratio is? 2. To the what power? N power. How many terms will you be adding up here? 7. Big number minus, or top number minus the bottom, add 1. When it starts at 1, it's really easy. It's always going to be the 7th. Or it's always going to be the top number. If it didn't start at 1, remember you have to do top number minus the bottom number, add 1. Over 1 minus 2, and simplify. So this would give you 6 times 1 minus 2 to the 7th power is 128. Over 1 minus 2 is negative 1. You can simplify that. 6 times negative 127 over negative 1. Negatives will cancel each other out. And really, on your calculator, you now just need to do 6 times 127, which gives you an answer of 762. That is your answer. Questions on how I did that? Okay, make sure that you write down the homework for this. Okay, make sure that you write down homework. Homework is going to be on page, let's see, 814. You are doing numbers. Page 814, you guys are doing numbers. Sorry, I lost my page here. 3 through 36, multiples of 3. So count by 3s, just like we did yesterday, 3, 6, 9, 12. And 49 through 53 odd. Page 814, numbers 3 through 36, multiples of 3. And numbers 49 through 53 odd. Remember, everything is collected. Hey, we'll put up the book underneath here if you'd like to. You're welcome to take a camera phone picture of it. Otherwise, you can work on it at home.